Okay, so going back to that differential equation we saw earlier, we know that our general solution is given by this, except that we know it's actually just an infinite collection of different solutions, each one differentiated based on this value of c. So now that we know how to think of initial value problems, we're going to add one piece to this question. We're going to add sort of a part B. So here, part B, we're going to look at finding the particular solution to this differential equation that satisfies the initial condition where y of 0 is equal to 2. So again, I want to keep coming back to this idea that really these initial conditions are just points on the curve. This is saying that if x is 0, y should be equal to 2, and we want to find the one specific curve in our general family of solutions that passes through this point 0, 2. Okay, so this process always the same. We're going to now just go and figure out what is this constant c in our general solution, and we're going to do that using the point 0, 2. So we know our general solution is the third root of x to the 3 plus 3 times c. So it's tempting to just go right to this equation and plug in x equal to 0, y equal to 2, and solve for c. And that's doable, but it's definitely not the easiest way or the fastest way to go about it. What I would strongly recommend is go back to the work that you would have done earlier in this problem. Okay, so this is the work that we did before. We started off with our differential equation. We separated it, and we integrated. And this is what we had as soon as we had first integrated. This is very much what I want to go back to. Okay, so if you're going to solve for c, you'll notice at this line, I have c here completely on the right hand side. If I want to solve for c, I can plug in x and y and solve for c very easily. Okay, so here I just want to go back and we'll make a note. If I want to solve for c, this is where I'm going to do it. So use this equation to solve for c. Okay, so let's copy that. And this is what we have, with a whole bunch of other stuff that we don't need. We want to solve for c. Okay, so we plug in x equal to 0, y equal to 2. We get 1/3 2 to the power of 3 on the left is equal to 1/3 times 0 to the 3 plus c. That's just going to be 0. So what we end up here on the left hand side is going to be 8/3 is equal to c, and that's about all the work that is required here to solve for c. So if we know what our c value is, then our final particular solution should be that y is equal to the third root of x to the power of 3 plus 3 multiplied by c, but 3c is actually just going to be 3 multiplied by 8/3, and so those are going to cancel each other out, and all you get here is x to the 3 plus 8. That's going to be our particular solution. So this is pretty much the format that these questions are going to take. Okay, there's two types of questions really. Are you looking for just a general solution? And in that case, if you're looking for a general solution, you're not going to be given an initial condition. You're not going to be given a point on the curve. Okay, and the second type of question is what we just did here, where you are given that initial condition, you're given your point, and you have to go and solve for c. Okay, so now that we know the structure, let's take a look at some more complicated examples. Let's sort of see what can go wrong in these questions.